Welcome back to Statistics with Mr. Walton. Today we're going to talk about Chapter 10 from the Practice of Statistics, the fourth edition, which is Section 1, most specifically, which is a two proportions z-test or two proportions interval. All right, so let's look at our overall complicated notes that we need to keep track of. Let's keep track of this by noting, if we look on our green formula sheet, we will get the generic for our SEs. Remember, these are our two SEs. If we have a significance test, then we're going to use our p hat sub c, which again, as we talked about, is our combined p hat value. All right, so combined p hat trumps. We still have our three conditions, so we still need to remember that we will be sinning either way. It doesn't matter. So we have S for randomness, so SRS, that's to remind us about our SRS, our random allocation if it's an experiment. We have I for independence, and then we have normality. Now if we look at our normality condition, we have slightly different here, and we talk about the fact that these could be conservative or not, but we need to show that our sampling distribution is approximately normal. Now realize, please realize, we're not talking about plural, we're talking about one. The sampling distribution, this is just one distribution that we are referring to, because we are talking about combining our data together to calculate a test statistic so that we can check on how likely something is, or so that we can create an interval using the information we have appropriately, if we can use a normal approximation for our sampling distribution. That is what we're allowed to talk about. All right? So don't get all hyped up. Also, don't forget, if you want to use your calculator, all right, you may. I've given you a little calculator here, a little calculator here. So that's what we want to talk about. Now, as we said in class, I do want to give you a little bit of a reminder about a few things. Number one, S and I, our first two conditions, they're both about the sample. In this case, it'll be the samples, whereas N is saying all about our sampling distribution. Just the sampling distribution. Okay? We might use our samples to talk about the sampling distribution, but there's just one sampling distribution. Versus when we talk about randomness or independence, in this case we're going to have two samples, then I want to talk about those two samples in those two conditions. All right, that's a little bit of a review. Let's move on. Okay, so we're going to read this. Hopefully you're going to read this. And then we want to ask ourselves, is this an experiment or an observational study? Part 1. Then it says, explain your answer. Okay, so think about it and then write your answer. Hopefully you got experiment because the two groups were randomly assigned treatments. All right, if they don't know which treatment and they are subjected to receiving a treatment, that means it's an experiment. Now, let's look at what we're going to do for part 2. Our part B is give appropriate statistical evidence to support a test based off of the health experts. So let's set this up. Okay, we have our two proportions for our parameters, and then we have our null and alternative hypothesis. So let's set this up. You guys try it and then you'll see mine. All right, so for my first proportion, I said that's the proportion of students not getting the flu with vitamin C. My second proportion is the proportion of students not getting the flu with the placebo. Our null hypothesis is there's no difference in the proportions. Our alternative is that P1 is greater than P2, which is proportion with vitamin C is going to be higher than the proportion taking the placebo as far as preventing people from getting the flu. So then we look at our summary stats real fast. So we have P hat sub 1 is equal to 101 over 403, which is 0.2506, which means our x1 is equal to 101 and our n1 is equal to 403. There we go. Then we also have our p hat sub 2, which is equal to 74 over 405, which is 0.1827, and our x sub 2 is of course 74, and our n sub 2 is 405. So that's our overall individual for each proportion, and then let's look at our combined summary stats. Okay, and since we're talking about a test, first thing that comes to mind is I want my p hat sub c. All right, and I get 0.2166, and please remember, this is the p hat that we want to use for all other things, right? Please? Yes. Excellent. All right, and then we have our z. All right, here we go. All right, so we have our summary stats, and we're ready to look at our next step, which is the conditions. Okay, so why don't you guys try to write them out, and then you'll see mine pop up. Ready? Go. All right, so the students were randomly assigned treatments, which meets our randomization criteria. It is reasonable to assume the two sample groups are independent of each other and that the individuals within the samples act independently of each other, as there should be more than 4,050 and 4,030, which is 10 times our sample sizes, of students available for each group. And since n1 times p hat sub c, etc., with my calculations, show calculations, are all greater than or equal to 10, then the sampling distribution should be approximately normal. Since all my conditions have been met, I will continue and calculate a 2-sample significance test for proportions. And then I told you that for me, I'm going to use my beautiful, wonderful Z to set this up, if you guys remember. So I'm going to say probability that Z is greater than, show my picture, and we'll scroll down so it makes it easier to see. 0, oops, sorry about that. then I'm going to run normal CDF on that z-score. And if you do so appropriately, I'm hoping that you get 0.0096. All right. And notice we didn't have an alpha level, so when we talk about our money statement, our conclusion in context now, we can say since my p-value is lower than any typical alpha level, I will reject H sub O. Now remember, typical alpha levels, 0.1, 0.05, 0.01, and 0.0096 is lower than that, so be careful about your rounding. But what does this mean in context? The evidence suggests that the experts were correct. Vitamin C does help prevent flu occurrences. All right, hopefully this helps and you learned a little bit, and I hope you had a little bit of fun. AP Statistics is done.